All right, this lesson is going to be on horizontal asymptotes. Now, with horizontal asymptotes, if I'm looking at that base function, our base rational function 1 over x, what I can see is that there can be, we've talked about vertical asymptotes. I know that since this is in the denominator, it's going to have a vertical asymptote at x equals 0. But what this is also going to do is it's going to have a horizontal asymptote at y equals 0. Now, different rational functions can have different horizontal asymptotes, but what I can see is there is going to be a horizontal line, and in this case it's y equals 0, where that function is going to approach that y equals 0, but it's never going to touch it. So let's take a look when x is 100. F of 100 is going to be 1 over 100. And no matter how big that gets, whether I put 1,000 in there, 1,000,000 in there, it's going to get closer and closer to that y equals 0, but never touch it. Same thing as it goes negatively. As f goes really, really negative, let's say negative 1,000, that is going to be 1 over negative 1,000 or negative 1,000. Really, really, really small, but it's never going to reach 0. And that's going to be our three cases that we need to worry about is where is there a horizontal asymptote and if there is a horizontal asymptote. So the first one, the first case is that the degree is larger on the denominator. So basically, there's going to be a battle between the numerator and the denominator, and one's going to win. Well, not always, but what we're doing is we're going to basically take a look at who's going to win. So what I've done is I've graphed a couple or got a couple rational functions, and we're going to take a look at the graph. Now what we can see, if the degree is larger on the bottom or on the denominator, there is always, always, always going to be a horizontal asymptote at y equals 0. Because what happens is when the denominator, in that battle between the numerator and the denominator is going to win. Its power is going to overpower the numerator, and it's going to drag that y value down to 0. So as you can see, this y value on each one of these is going to approach 0. Because on this first example, the degree on the top is 1, the degree on the bottom is 2, so the denominator is bigger, so it is going to take over and always going to be a horizontal asymptote at y equals 0. Now on here, there is not going to be, the degree is 0 on the top, and the degree is 2 on the bottom. So again, degree on the denominator is larger, horizontal asymptote at y equals 0. And it doesn't matter if there's a hole. So in this case, there is a hole here at x equals 3, a vertical asymptote at x equals negative 4, but again, that is not going to change where the vertical asymptote is. So if we're taking a look at the horizontal asymptote in general, all I've got to do is I've got to look for where the degree is higher, whether it's on the top, bottom, or are they equal. Again, if they're higher on the bottom, it is always y equals 0. The case number 2 is that the degrees are equal. So if the rational function, the degree is the same, I don't care what that degree is, if it's the same, that battle between the top and bottom, they're equal. So they are going to balance each other out. And what I'm going to do, and where that horizontal asymptote is going to be at a y equals the coefficients, or I'm going to say the leading coefficients of the highest degree. There is an h in highest. Now, in this first one, it is negative 2x squared minus 4x all over x squared plus x minus 6. Now, the degrees are equal because the degree of the top is 2 and the degree of the bottom is 2. So all I'm going to do is find the highest degree, which is 2, circle the coefficient. Remember, if it isn't written there, it is 1. So this horizontal asymptote is going to be at y equals negative 2. And you can clearly see that that function is going to even out at negative 2. Here, this is negative 2 as well, because there is a negative out in front. Both degrees are 1. Leading coefficient of the numerator is 1, and the leading coefficient of the degree of the top is 1. The leading coefficient is 2. The degree of the bottom is 1. Leading coefficient is 1. That is y equals negative 2. And again, all reflected in the graph. So if we were to graph this in our calculator, we would still have that horizontal asymptote at y equals negative 2. Next, I should say, again, even if there are holes, even if there are vertical asymptotes, I am indifferent to those when it comes to horizontal asymptotes. The degree of this function, the degree of the top is 2, the degree of the bottom is 2. So the one out in front of there, this horizontal asymptote is going to be at y equals 3. And again, reflected in the graph right there. A y value of 3. Now the biggest difference is this is it going to be a y equals. So where vertical asymptotes, horizontal asymptotes, and holes occurred at x equals, this is going to be at y equals. So again, on this last one, for horizontal asymptotes, the degree of the top is 1, leading coefficient of 1. Degree of the bottom is 1, leading coefficient of 3. So that is at y equals 1/3. Again, right here at 1/3. Always take a look at your graph. It should show you where everything is. Case number 3 is if it's higher in the numerator. Then remember that battle between the numerator and the denominator. The numerator is going to take over and take off and make that y value higher and higher or lower and lower. If you see the degree of this one, the degree is 2, leading coefficient of 4x. What this is going to do is it's never going to reach a single y value. It is going to continue on forever. So what we're going to say is that there is no horizontal asymptote if the degree of the top is bigger. Same thing with this one. The degree of the numerator is 3, the degree of the denominator is 2. There is going to be no horizontal asymptote. Now, it doesn't matter if it's 1 bigger, 2 bigger, 3 bigger in the numerator, it is going to be no horizontal asymptote. This one it's factored, but if I were to multiply this together, I know the degree of the top is x to the 3rd. Now, there is going to be some trailing stuff. The degree of the bottom is 1. So I know that as the degree of the top is 2 larger, there is not going to be any horizontal asymptote because it's not going to level out anywhere. Okay, so horizontal asymptotes is just about finding where the degree of the top or the degree is larger. Top, bottom, or are they equal? Now, so what we're going to do is we're going to take a look at different ones, say where are the degrees equal, or where are the degrees, what are the degrees of the numerator, degree of the denominator, and what does that mean about my horizontal asymptote? Now, what I'm going to see on this one, the first one is 3x plus 6 over x squared minus x minus 2. The degree of the top is 1. The degree of the bottom is 2. That is a horizontal asymptote is at y equals 0 because the degree of the bottom is larger. Same thing here. The degree of the top is 1. Degree of the bottom is 2. Doesn't matter anything else. That is at y equals 0. Again, if you wanted to graph these, it would show you that. Here, the degree of the top is 2. The degree of the bottom is 1. The degree of it's higher in the numerator, so there is no horizontal asymptote here. In this example, I have f of x equals negative 2x squared, so the degree of the top is 2. The degree of the bottom is 2. So that is going to be at y equals -2 over 1, which is -2. Again, always graph them out and take a look at the graph. Here we go. Degree of the bottom is larger here. Degree of the top is 0. The degree of the bottom is 2. So that's going to be y equals 0. Here, the degree of the top is 3. Degree of the bottom is 2. Larger on the top. That is no horizontal asymptote. Here, degree of the top is 1. Degree of the bottom is 2. So that is going to be y equals 0. Here, larger on the top, that is no horizontal asymptote. Here, I have degrees of 1 here, so that is equal, so that is y equals -2 over 1, or -2. Here, it is y equals 0 because it's larger on the bottom, and here, degree is 2 on the bottom, degree of 2 on the top, degree of 2 on the bottom. Leading coefficients of the highest degree are 1 over 2. So that's y equals 1/2. You should now be able to fill in all the horizontal asymptotes in that homework.